Hello students, this is SAHA tutorial. Today I discuss a very important topic from matrix and diagonalization of matrix. The important topic. Wait, I must appeal to all of you to subscribe this channel. If you have not subscribed, subscribe, and if you like, then like. If you have any suggestion, then comment me. So let's start. Diagonalization of matrix. First, we know what about similarity transformation. Similarity transformation. Similarity transformation is that between two square matrices, we are taking two square matrices A and B. A and B are two square matrices. Are two A and B are two square matrices. Two square matrices of any order. Matrix. So what is important? We have to represent a matrix through another matrix, and of course it cannot be equal, and they may be unequal. So how a matrix can be represented? I want to represent B matrix of same order. Matrix of same order. Both are matrix. Two matrices of same order. Same order. So I wish to represent B matrix through A matrix. So I will use another matrix which is called model matrix. Each called model matrix. Through the model matrix of same order, model matrix same order, we can represent a matrix A matrix B through A. Model matrix is called model matrix. So such kind of transformation from A to B is called similarity transformation. So this transformation is called similarity transformation. So this is important to diagonalize any matrix. So and one thing is to notice that P is a model matrix which transforms A to B. So now we discuss about diagonalization of matrix. Diagonalization, very important topic. If you know the property of diagonal matrix, then you can understand that what is the importance of diagonalization of matrix. Very, very important, because eigenvalues, eigenvectors are important topic in linear matrix, and it is related with this. Diagonalization means we can transfer any matrix A, any matrix A, any square matrix and we used to transform it to diagonal matrix. If you can transfer any matrix in diagonal matrix, then you can very easily understand what is the eigen values of the matrix. Eigenvalues of course occur in the diagonal form on the diagonal elements. So that's why diagonalization is very important. So is any square matrix, and through similarity, as I have said, square matrix. So through similarity transformation, we will transform it to diagonal. In diagonal form, A changes to D because we take A changes to D. So we have must need a model matrix. We are taking P, which transforms A to D. This is the diagonal matrix. Diagonal matrix means all the eigenvalues are in the diagonal elements and the non-diagonal elements are zero, equal to zero. So how we can take change it? So we take a model matrix and we transform through similarity or similarity transformation on A, and we can get diagonal matrix. So the model matrix can be anything. That is the question. So we cannot take any from any matrix, a model matrix. We have to select in such a way that we have to take the model matrix that uh, you have to uh, create find out all the eigenvalues and related eigenvectors also. Eigenvalues first and eigenvectors, and through the eigenvectors you can make the model matrix. The model matrix always formed by the eigenvectors of the matrix. Then you can very easily transform it to a diagonal matrix. You also note that on the diagonal element you always find the eigenvalues. So I will give an example. Let's start an example. Let E is a matrix, the matrix given by -2, 2, -3, 2, 1, -6, and then -1, -2, and 0. So this is our square matrix of three order, third order square matrix. So this is to be transformed into a diagonal matrix. So we need first eigenvectors. So for eigenvectors, we need to first need eigenvalues. So we know the characteristic equation is that A minus lambda I is equal to 0. It is the required condition uh, for being A to be it is the characteristic equation of A. I'm not going much on this topic. Uh, just I'm calculating the eigenvalues of the A. So solving this, we can uh, find out the characteristic value or eigenvalues. So I am solving it. We can very easily solve this. Now this is a determinant -2 minus lambda 2 minus 3. This will be 2 This will be 1 minus lambda. This will be minus 6. This will be minus 1. Minus 2. And this will be minus lambda. So this determinant should be 0. So here we will get it will be a equation of of lambda of uh, mm, uh, the third order equation of lambda. So we solving this we get three eigenvalues. So we solve this first. So how can we solve? We are taking this first row to solve it. So there will be minus 2 plus lambda. Here we will get minus lambda plus lambda square. There will be plus 8 minus 8. So minus 8 and minus 2 8 not sorry. I waited 12 will be minus 12 lambda square minus 12 and this will be minus 2 minus 2 lambda plus and minus 6 and at last will be minus 3. There will be minus 4 plus 1 minus lambda is equal to 0. This is a cubic equation and solving this we will get 3 roots of the lambda. Here I need here we will get multiplying with this minus minus 2 lambda plus 2 lambda square minus 24. We can there are three minus, one minus, two minus here and also here minus. So we are discard minus and take there is plus. And discarding minus. This is plus, this is plus, and this is plus. So this is plus minus 2 lambda and this will be minus 24 plus minus lambda square plus lambda cube cubic equation and this is minus 12 lambda. Then we will get plus minus minus lambda minus 12. This will be again minus 12 plus 3 minus 3 lambda. We have to solve in a short form. If we solve, then first I write lambda cube, then there is minus lambda square, 2 lambda square, and here is a lambda square. So if we minus subtract, it will get 1 lambda square, and lambdas are minus 2 lambda minus 2 lambda. Here is minus 12 lambda, there is minus 4 lambda, minus 3 lambda. So all are negative. So you can add 2, 12, 14, 14, 4, 18, 18, 3, 21. So minus 21, 14, 18, 21, minus 21 lambda. And at last the digits, and minus 24, minus 12, minus 12, and plus 3, minus 12, minus 12, minus 24, minus 48, plus 3, means minus 45. So if we put lambda is equal to, I have already done in my exercise. We will put lambda is equal to 5, then this will be, this will go to equal to 0. So lambda minus 5 will be one factor of this. So I am taking lambda minus 5 and dividing by this lambda minus 5, we will get dividing by lambda minus 5, we will get lambda square plus 6 lambda plus 9 is equal to 0. So it is now very easy to solve. So lambda will have, therefore the root 5, and here the lambda plus 3 whole square is minus 3 and minus 3, minus 3. So these are the required eigenvalues. Now we have to find out the eigenvectors. So that's why first we put 5 in the characteristic equation to find out the so our to find out the eigenvector we have to solve a minus lambda I into e is equal to 0. If we solve, then we can get the required eigenvectors relative to the lambda. First we take lambda is equal to 5 and put lambda is equal to 5. We will put a, and so x is equal to is a column vector x y z, x y z. So I will solve this. Look this. So lambda is equal to 5, and I am finding the eigenvectors. I just find one eigenvector, and your homework will be to find out the other eigenvectors. your homework must do. I'm showing how to calculate eigenvectors A minus lambda I x is equal to 0 vector of same order. And now each I'm putting A was minus 2 minus 2 2 minus 3. There will be 2 1 minus 6 minus 1 minus 2 0, and this will be multiplying with identity matrix. There will be 5 0 0 0 5 0. There will be 0 0 5. So I have to subtract. Here is both are order 3 or 3 order matrix. So the zero matrix also will be of order 3. I am not writing of order 3 zero matrix. Now if we subtract, we will get minus 2 plus minus 5. This there will be minus 7. Sorry, and even x. There will be also x. Here x will be a column matrix x, y, z. So this will be equal to 0 matrix. Minus 7, 2, minus 3, minus 3. This will be 2, 6. Oh, sorry, minus 4, minus 4, minus 6. There will be minus 1, minus 1, minus 2, and this will be minus 5. X, Y, Z, X, Y, Z. So they will be equal to, I am taking now 0 as a column matrix. 0, 0, 0. So we will get 3 equations from this. We know matrix multiplication. I already watched a video about matrix multiplication. Look this. If you don't know how to multiply matrix multiplication, it is very easy. I am again to tell you the row and the column we will take. For each row and each column we will take. So here we will get 3 equations: minus 7x plus 2y minus 3z is equal to 0. 2x minus 4y minus 6z is equal to 0. There will be minus a minus 2y minus 5z So such kind of equation of three variables, we don't have to solve. We don't need to solve each one. We can take two equations and can evaluate the value. So there will be solving these two equations, we will get very easily the solution. If we will take this by cross multiplication, uh, cross multiplication formula, we can solve it taking ax, there will be minus 12 and again minus 12. There will be y, this will be minus 6, this will be minus 42. Last, this will be 28 minus 4. So if we solve this, we get the value of x, y, z. X will be minus 24, y will be minus 48, and z will be 24. So you can further reduce it by dividing the denominator by 24. This is 24. We will x will be equal to minus 2, y is equal to minus 1. This will be minus 1, and y equal to minus 2, and z equal to 1. Z by 1. So we can take at least one value of the vector eigenvector related with 5. I am writing eigenvector related with 5. This is eigenvector related with 5 will be one solution, one eigenvector. This is minus 1, minus 2, and this is 1. So one eigenvector I have found out one eigenvector, and this is your homework to find out the other eigenvectors. I am writing other eigenvectors also. You can solve and can calculate. For lambda is equal to minus 3. The eigenvectors will be, so one eigenvector we have obtained. This is minus 1, minus 2, 1. Other eigenvectors you have to find out. X2 will be x2 will be 2 minus 1, 0, and other eigenvector is, third eigenvector will be 3, 0, 1. For students, I must advise all of you must calculate and find out this to strengthen your base in matrix. Must find out, must do this homework. I must advise all of you. And if you have any problem, then comment me that you have any problem to find out such kind of eigenvectors. If you have any problem to find out eigenvectors, then comment me. Okay, I'll describe in another video how you can find out if you have any problem. So we have already three eigenvectors. Now you can make model matrix very easily. P, the model matrix, it will be just taking the eigenvectors value. We can make it minus 1, minus 2, 1, 2, minus 1, 0, 3, 0, 1. So if you have find out the model matrix, then P inverse also you can easily calculate if you know the way. I am just writing. I have already done my exercise book. I am writing. I am not calculating it. It will be 1 by 8 minus 1 minus 2 3 2 minus 4 minus 6 1 2 5. Now this is our inverse of the model matrix. So we have to solve just to get diagonal matrix D. We have to solve this transformation P inverse A, and if we put all these matrices, then we will get. I have already done my exercise book. Your work, it is your homework to done your on your exercise book to the rule I have explained and find out that I have what I have explained. This is right or wrong. It is your homework. So as I have said that in the diagonal matrix you must find out the eigenvectors. You can remember eigenvectors were 5 minus 3 minus 3. So I have already opted. So I have found out that all the eigenvectors occur in the diagonal elements. So diagonal is very important to find out the eigenvectors in a diagonal element, and also diagonal matrix have many more properties in the linear matrix application. So diagonalization you must have to learn how to easily you can diagonal any matrix. So I hope this video will help you. Thanks, and if you like the like, if you subscribe, then subscribe this channel. And thanks for watching. Have a good day.